Hey guys, this is Darshan Lokhande. I am a pre-final year BTech CSE student at IIIT Pune. Welcome to our channel Learn Competitive Programming with CodeChef. If you are interested in competitive programming and want to learn data structures and algorithms, this is the one-stop destination for you. We post weekly problem explanations and concept videos. So don't forget to subscribe to our channel by hitting that subscribe button and also the bell icon. Also, did you know that CodeChef also conducts free live classes on Unacademy where we teach every possible topic on competitive programming? We have beginner level courses like Introduction to Programming in C++ or Java, basic data structures, recursion, as well as advanced courses like dynamic programming, graph theory, and segmentaries. These courses are conducted by top coding experts who have been ICPC World Finalists, IOI medalists, or have worked in top product companies like Facebook, Google, Amazon, LinkedIn. All you need to do is download the Unacademy app or register yourself at unacademy.com and select your goal as competitive programming. You can also take the paid plus subscription to get additional features and individual level support. In plus subscription, we have a large set of problems associated with each topic covered. Not only that, we also have 6-star and 7-star rated teaching assistants to clear all your doubts during and after the live sessions. Also, don't forget to use my referral code DarshanCool25 while subscribing to get an instant 10% discount. The problem that we are going to discuss today is even sequence. The problem appeared in December lunchtime and has a difficulty level of easy medium. The prerequisites for this problem are dynamic programming. Our agenda for today's video is going to be as follows. First, we will walk through the problem statement and try to understand what the problem is trying to say. Then, we will go through the detailed solution approach of the problem step by step and then have a quick go through of the C++ implementation. The problem statement goes as follows. We are given an integer sequence of n numbers and we have to find the minimum number of operations to make it an even sequence. And the operations that we can do is that at each step either we can delete an element from the current sequence or insert an integer anywhere in the sequence. But now let's understand what do we mean by an even sequence. So there's a definition given over here, but I will try to explain it in easy terms. So an even sequence is basically a sequence in which every maximum size subarray having equal elements is of even length. What do I mean by that? Let's see through an example. So you can see over here that in example 1, if I break my given sequence into subarrays of equal elements, so like this, then you can see that all of them have even length. That is, here the length is 2, 4 and 2. So we can say that this is an even sequence. But here if we break the given sequence into subarrays of equal elements, maximum size subarrays of equal elements, not all are of even length. That is, this is of length 4, this is of length 2, this is of length 1, right? So this is not an even sequence. So yeah, basically this is the definition of an even sequence, and by performing minimum number of operations, we need to convert the given sequence to an even sequence. And we just have to output the minimum number of operations. We don't have to actually output the sequence at the end. Now, to begin with our solution approach, we have two kinds of operations, that is insertion and deletion, right? Now, definitely every sequence can be broken down into maximal subarrays of equal elements and they definitely have a parity, right? For example, in the example in front of us, the parity can be written as uh, like there is odd number of threes, then there is even number of ones, and again there are odd number of twos. So definitely this is not an even sequence, as for an even sequence all the parities should be even. Now how can we make them even using the insertion operation? Easily, the parity can be switched by just adding a single number to the odd ones. That is, in one operation, I can add a 3 over here, and in one operation, I can add a 2 over here. So that will change the all parities to even. And now this is an even sequence, right? So this could be achieved using how many operations? Two operations. One operation was utilized here and one was utilized over here. But notice that the same thing can also be done using the deletion operation. Why? Because switching parity does not mean that we can just add elements. We can also remove a single number to switch the parity. That is, initially uh, the sequence looked like this. So I'll just erase this and bring it to original one. Yeah. So initially the sequence looked like this. So what I can do is I can remove a 3 from here. So now the parity is become even because there are 0 threes, and also I can remove a 2 from here and again the parity is even. So the same task which was done using the insertion operation, we are also able to do using the deletion operation. So but then which of them is better? Notice that we can see this through some example that deletion is a better operation. Why? Because consider a case like this where there are odd number of numbers. Let's say there are three threes, a 2 over here and a 3 over here. So usually what you would do is that you would utilize three operations to convert this into an even sequence. Add a 3 over here, add a 2 over here and add a 3 over here. But the same can be done in just one operation. How? Just use the deletion operation to remove the 2 from here, and in just one operation we have an even sequence with us. So definitely deletion is able to do the same task as insertion, but in some cases it is doing even better. So in our solution approach, we would only be utilizing the deletion operation. And what that means is that initially there would be a sequence given to us, and we would be deleting some elements from that. So whatever remains would be our final even sequence. Or to put in other words, the final sequence which we would be getting would be a subsequence of the original sequence. So let's say this is the original sequence A and this is the answer. Then answer is nothing but a subsequence of A, and at the same time it is also an even sequence. So now let's see that how to perform these deletion operations so that this even sequence is as big as possible, because we want to minimize the number of operations. So if you want to minimize the number of operations, the end result that we would be getting, that is the subsequence or the even sequence, that should be as big as possible. So now the modified task at hand is to find the longest subsequence of the given sequence, which is an even sequence. That is, we would be given an input sequence and we have to find its subsequence, which is the longest as well as it is an even sequence. So definitely we would be getting this subsequence by deleting some elements from this original sequence. And for this task specifically, we would be needing the help of dynamic programming. So let's see how dynamic programming helps us maintain the length of the longest subsequence, which indirectly leads us to the minimum number of operations. So first of all, the dp of 0 would maintain the length of the longest sequence, which is an even sequence. So initially when we have not read any input, that is the given input sequence, let's say A, we have not started reading it yet. Initially the value of dp of 0 would be definitely 0. And the other part is that for other indices, that is dp of x, dp of x would store the largest odd length even sequence with an unpaired x. So what do I mean by that? For that, I have some visual aid over here. So as you can see over here, there's a double-headed arrow. So assume that a double-headed arrow indicates a even sequence. Okay, so this is a even sequence with an extra x, and this is just an even sequence. And now assume that the red brackets are the largest operator. So what does this diagram denote? This figure denotes the largest odd length even sequence with an unpaired x. That is, this sequence is largest. It also has an even sequence, but there's an unpaired x over here. And on the other side, this is the largest even sequence, which is nothing but dp of 0. Basically, this is nothing but dp of 0, right? So so we would always be maintaining their lengths in our DP array, and the following notation would be used at all times. And what is the initialization? The initialization is that the DP of 0 would be initially 0 because we haven't read any character or any number. So the length of longest even sequence is also 0. And at the same time, dp of x, that is largest odd length even sequence, we would be initializing this as some very negative number. So let's say we can initialize it as int min maybe, or you can maybe imagine this also as minus infinity. Okay, so some very negative number. And now one by one, when we read the numbers from the given input sequence, let's call that number as x. We have two options with us. Either we put that number over here, that is, we extend this largest sequence with an x, and now if you observe, this is an even sequence, okay, a double-headed arrow. Or else we can place this x over here, and now you can see that this is no more an even sequence, but it is a potential candidate for future even sequence. Why? Because if you see, this and this look similar, right? So this is a potential candidate for a future even sequence. So what we do in both these cases, we check whether they are maximal in length or not. What do I mean by that? Let's see. So basically, if you observe, uh, according to the notation we are using, this is nothing but dp of x. When we have read the element x, okay, and we are about to place it over here, okay, we haven't placed it yet. Before that, this is nothing but dp of x, and this red bracket is nothing but dp of 0, okay. And we definitely know that this is of odd length. Why? Because this is an even sequence plus an unpaired x, and this is definitely of even length. So I can rename this as, let's say, odd, and I can rename this as even, not rename, but make a copy it into a temporary variable. And now you can see that the new length would be what? The new length would be odd plus 1, right? Because this was an odd length sequence with an unpaired x, and we have just added one more x. So this is odd plus 1, the new length, and over here the new length would be even plus 1. Okay, because initially the length was even, and now we are adding an extra x, so the length is even plus 1. But where to update these lengths? Now after adding this x, if you observe, this whole thing this whole thing in the green is now an even sequence. Not necessarily the longest, but it is an even sequence, right? So it is a candidate for dp of 0. So what we do is that we write the following statement, that is dp of 0 is equals to max of odd plus 1 comma whatever was the initial value of dp of 0. Okay, and on the other hand, if you observe this thing in the green, this whole thing now is a potential candidate for dp of x. It may not be the longest odd length sequence, but at least it is a candidate, right? So at each step, to maintain our dynamic programming, we have to update dp of x using the max function. So similarly, here also we write dp of x is equals to max of e1 plus 1 comma whatever was the initial value of dp of x. At the end, we want dp of 0 and dp of x to be as maximum as possible because we want the maximum length, right? And that's it. We continue this process. We update dp of 0 and dp of x for each x, that is for each element one by one. And once we have iterated over the whole input, that is the whole input sequence, finally whatever is the value in dp of 0, it is the maximum even sequence that we can get from the given input sequence. So the implementation of the problem is pretty straightforward, exactly on the lines of what the discussion we just had in the solution approach. So for each test case, we take the input n and we initialize our dp array or vector with int min, that is a very negative number. You can assume it to be minus infinity. And before starting our iteration, we initialize dp of 0 is equals to 0 because we know that dp of 0 denotes the longest subsequence length, which is also an even sequence. So before starting anything, its value would be definitely 0, right, as discussed in the solution. And after that, we run a loop from 0 to n minus 1, and each time we take the input, that is the current element in this input sequence, let's call that element as x. And for that element, we know that dp of 0 is of even length and maximum, so we make a temporary variable even, and similarly we make a temporary variable odd, that is dp of x, which contains an unpaired x at the end but is largest in the length. Okay, and we update the dp of x and dp of 0 again using these even and odd values. That is, dp of x can be either same, that is it can remain the same, or it can be even plus 1. Okay, that is a new value, so whatever is the maximum will be stored in dp of x. Or we can add the current x to the unpaired x and make it of even length. So dp of 0 is equals to odd plus 1 over here, or we can keep it as it is, as it was earlier, whichever is the maximum. And we do this process for each of the input elements in order from left to right. Okay, and once we are done with that, finally we have the value of dp of 0, but we have to output the operations, minimum number of operations, that is as discussed deletion operations, and that is nothing but the total length n minus dp of 0, because dp of 0 is the maximum length even sequence, so n minus dp of 0 is the minimum number of operations. And that completes our solution. Now, without wasting any time, let's submit this code on CodeChef ID and let's hope for a quick AC. Great, so our solution works.